Hi guys, for today's class I will be showing you some basic collisions with particles and also how to manipulate attributes. Uh, I have fresh Houdini here, and to start I'm just going to create a circle object. So just in the viewport, hit tab and type circle, hit enter and hit enter again, so it creates a circle in the center. And then this is the top level. We always want to work inside, never change any transformations in, so I'm just going to double click and go in. And this is my circle object. I'm just going to maximize the viewport. And the first thing I'm going to do, since this is going to be our particles emitter, I'm going to increase the amount of divisions so we get rid of this polygonal shape. So I'm going to put to something like 32, and I'm going to use a remesh node to add some polygons inside, since we will be using noise to distort this circle. One thing I want to do before the remesh is, actually I'm going to do it after. So with the remesh, this is the amount of polygons, the resolution. So if we lower it, we'll get more polygons. So I'm just going to put something like 0.1, maybe like 0.075, yeah, something like this. And iteration just smooths it out just a little bit. After this, I'm going to put a transform. So if we want, we could put this above the ground using this manipulator. See, I don't have the transform display on, so we're not really seeing what we're doing. So if I turn it like this, now I see what's happening after the transform node. So I'm going to lift it like this. Let me see, so this is 1 by 1. I'm gonna make the size, the scale slightly bigger, something like 2, maybe 1.5, and just lift it a bit more. So we're getting something like this. This would be our portal for particles coming out. And now I'm going to use a node called attribute noise. And this node is very useful if you want to add noise as an attribute. That's why it's called attribute noise. So I'm just going to type in and this is a new node in Houdini 17, so it's pretty useful. So if you take a look, it already started to add some colored noise. I'm just going to turn it to smooth into our geometry. And by the way, without this remesh, we're not going to see this much details. So first step you want to do after you put in the attribute noise is to make sure the noise is either centered or remapped to get the most of the contrast. So if I click on this, see right away we're getting more contrast. And the other thing is, like I said, if you take a look, we are getting all these details because we have the actual polygons to have those noise values on them. So if I turn off the remesh, see, it just looks very flat because we don't have polygons in the middle. So that's why it's very important to have enough resolution when you're working with geometry noise in Houdini. And the other interesting thing is that currently you could see that it uses the position of this object to add noise into CD. So CD is a color attribute, color diffuse, but we don't have to use CD. If we want, we could add noise to the position. All we need to do is just to change the CD to capital P, which is the position attribute, and hit enter, and this is what we get. We get something like this. And again, it's very important to have center noise even when you're adding it to position. Otherwise, if I click this off, see, it offsets it somewhere, and as we start increasing the noise, it will start pushing it into the invisible axis, which we don't want. Of course, we want to have our object where it is and just the noise to be distorting it. So make sure you have center or remap noise. Remap noise is for some advanced manipulation, but center should just be fine to use. So let's just decrease the size, and if you click on animate it, and don't forget to turn on real time, and you hit play, the noise will actually be pulsing, and the speed of the pulse is going to be controlled in here. So pulse duration, if you decrease it, it's going to pulse faster. So I'm going to put 0.5 and see it goes faster. If I put something like 2, it goes pretty slowly. And also we can control the element size, make it bigger or smaller. So I'm going to put something like 0.5 and 1.5 for pulse, and we get some nice interesting organic motion, as if this is like some kind of portal or something. So for now this is good for a collision geometry, and I'm gonna create a particle network right away and start emitting particles from this to see what we're getting. So I'm gonna hit tab, pop net, and click on this so we see our particles. And I'm just gonna hit D and go to geometry, and right now the particles are shown as these little dots, which are either disks or pixels. But if you actually want to see bigger particles in the viewport, you can change this in the geometry level, change this to points, and now you can actually see how big are your particles. And if you have some sprites, later on I'm going to show you how to use these. You can also use sprites, but right now they are not doing anything. So I'm going to keep my particle size to 2, and I'm going to go inside, and just like I was showing you guys in the first couple of lessons, this is what we get by default from creating a particle network. Everything is pretty much set up, so if you hit play, we see particles are just appearing every frame. So if you go to birth, Houdini creates 5,000 particles every 24 frames every second. And if we change this 5,000, if we put this to 0 and put activation, constant activation to 0, and instead we start putting particles here, this will show us the exact amount of particles that are being born every frame. So this is more useful if you want to have more control over how many particles are born. So I'm going to put something like maybe 1,000 particles per frame, and see, we're starting to get way more particles now, and this way we know exactly how many particles we have every frame. So right now we don't have any forces to push them around, so let's create some force. I'm going to type in pop force, and if you take a look, we want to push particles along the z-axis, and you can also see it here like blue, and that's why we're going to add values in the third row. So again, whenever you see 3 rows in Houdini, it means it's a vector, so this one is going to be X, Y, Z, or if it's a color, it's going to be RGB. So we're going to put something like 5 in here. Let's see. So right now they're going pretty fast, as you can see, and we're getting this stepping motion, which it's possible to fix this really easily if you go into, again, into the source. In the birth tab, there's this jitter, birth scale, birth time, and interpolate source. So the best technique I found is put this to negative and this one to back. And now if I hit play, see, we're getting smooth, jittered particles that are not showing a weird stepping. And the other thing we want to do is to add drag, pop drag. And this will slow the particles down. See, now we're getting more smooth going particles. I'm going to add slight force downwards. You're going to see just in a bit why I'm doing that. So I'm going to do minus 0.1. And I'm going to add some noise to the particle motion. So I'm going to put something like 2 and maybe 2.5 in the swirl size. And by the way, if you're not sure what the swirl size is, if I hit play, see how our particle is getting some noisy motion now. But if you're not sure what the size is, you can always click on guide, and this guide will show you what your noise looks like. So see, we're getting like not only noise, but this entire pop force. What is it doing? So see, we're getting these streamers pointing this way, so that means force is going this way, and we're getting the noise size. So if I increase this, the noise is getting bigger, and then if I decrease it, the noise is getting smaller. 2.5 is pretty good. I'm gonna change the turbulence. Turbulence is basically how many details you get in your noise pattern. So I usually like to keep it 2 or 3. So 2 is pretty good, gives like smooth, nice swirls. So now if I hit play, this is what we're getting. And I don't need the guide anymore, so I'm going to turn it off. So this is pretty good. Now let's add some colors using pop color. Okay, so this will add a constant color, which we don't want, of course, because it's boring. So I'm going to change color type from constant to ramp. And right now, since the particle age is 100 seconds, it's going to reach the whiteness only after 100 seconds, which is a lot of frames. So if we decrease this to something like 6 seconds and add some variance, 0.1, and go back, now if I hit play, see, we're starting to get more particles capture this range, because this is from 0 to 1 second. And for this example, I want to use I don't want to use age, particle age, so the newborn particles are black and the older are white. I want to use particle speed, because it will showcase the collisions better. So there's like this convenient drop down menu. If I click on this and change this to speed, it changed this expression code, and we're starting to get, we're not going to see it until we find the right range. So as soon as you switch to speed, this is no longer seconds, this is velocity length. So usually it ranges between 10 or 15, from 0 to 15. So I'm going to put something like 10, and I'm going to put something like 2 maybe 1 and 7.5, 1 and 5. So this way you're getting more contrast in your simulation. So see, we're starting to get some more contrast. So basically the faster moving particles are lighter. So let's put 3.5 maybe. And the darker ones are slow moving particles. Okay, so I'm going to change this color to something like purple. And let's start talking about collisions. So the easiest way you can start checking collisions and adding them is by creating a ground plane node. So I hit tab, type in ground plane, and ground plane is a very efficient collision plane that will make particles collide with the ground. So very important thing with the collisions every time you work in Houdini is that they always have to go and affect everything from the left to right. So basically you have your simulation here, doesn't matter if it's smoke or water or particles, and your collision always have to be on the left and connected first collision and then second your particles. And this is very important theory inside the dynamics network. So everything on the left will affect everything on the right, and then calculations go from top to down. And make sure you always have your orange flag on the output node, because if you have it on one of these, the solver will not calculate and your simulation is not going to work. So in order to make the ground plane affect the simulation, we just need to create a merge node. And again, very important, is first connect this and then this, so it's like left to right. Because if it's the opposite, let me show you. If it's like that, so see, it's crisscrossing, so this is on the left and this is on the right, collisions are not going to work, because see, this says left inputs affect right inputs. So very important, left, right. Make sure you have it connected like this, and you see this plane in here. So basically it creates an infinite plane. So even though we are seeing it only in the size of 20 by 20, even if the particles go outside, they will still collide with this invisible ground plane. This is just for our representation. So we can actually change this, make it bigger, but this will have no effect. It will always collide infinitely with it, and this is very efficient. We'll just make the color a bit darker and see what we get when we hit play. So ideally now the particles should start colliding with the ground, and if you see, they actually do. So if I increase the downward force something like 25, oops, I'm just going to reset and control click on this guy, so this reset. You see the particles go down and start colliding with the ground. And again, if I increase this to something like -9, you will see this right away. You see, particles are falling down and colliding with the ground. Just about balancing the forces. Maybe a value of 1 would be actually good. 0.98 to mimic gravity. Okay, there we go. So we have nice ground collisions, and we also have particles moving forward. So this is very simple collisions. Let me just check the time. For more advanced collisions, I'm going to show you two ways. One is a lazy but a slower way, and the other one is a more advanced way, the one like you would be using if you would be a professional effects artist. So I'm just going to go up and create a test geometry, like a little character. So see this rubber toy? So I'm going to create this guy, and if I have the blue flag on the particles, it will have the display on them. But then if I also want to see what else is in the scene, I can click on this purple one, which is a template. And this will show me the template geometry. So this is our little character that we're going to use to collide the particles with. So I'm going to put a transform node. I'm going to translate it like this. Up, and I'm going to scale it up like 2.5. A bit, and I'm also going to rotate it 180 degrees so it's facing the particles, something like this. So this would be our character that the particles are supposed to collide with. Of course they're not colliding now, so to make them to collide with some external object outside of the simulation, this is what we have to do. We have to put in a collision source node. Sorry. Collision source. And connect the character to this source. So this source will give us two outputs. One is just for simple collision linking, and the second one is for more advanced one. But the second one is very efficient and will calculate really fast. If you have huge scenes and complex collision geometry that is moving, etc., this method of linking two of these into here is the industry standard one. So usually this is the general workflow how you would do it. You create just a simple null, which is end of chain node. So you connect this to here, and you also copy it, and you connect the second input in here, something like that, and you name the first one out collision geo, and you name the second one out collision volume. So if you look at this one, this just looks like polygons. It doesn't have anything fancy. The only thing is that if the object is moving, this collision source node will calculate its velocity and make sure it's blended between frames and nothing weird is going on. But the second one, if you visualize it, it looks like some weird voxelized object, which actually is, because the volumes in Houdini are basically voxels inside this container, and voxels are little cubes that contain different information inside them. And basically how the volume collision works is whenever the particle is going to hit an object and try to go inside, the volume representation will do a test and say, okay, so I have voxels outside of this and I have voxels inside, and if the particle is going inside, it's going to get a negative value. So that's why I'm going to push the particles out, and this is how they're going to be sticking to the surface and bouncing off. This is just like an easy explanation of how voxel collisions work. So basically this, if you just start going inside, you could see that this is like a thin layer of voxels, and the more you increase the voxels, the more accurate it's going to be. The tighter the more tight they're going to be next to each other and not let any particles go through. So to control the voxel resolution, if you go to volume, here you have your voxel size. So this works a bit differently. Like, it's not like if you increase it you're gonna get more voxels. If you decrease the volume voxel size, it's basically make the voxels smaller and the resolution higher. So if I make this like 0.05, so see, we're getting more resolution out of our collision geo. So there are a few extra steps that you'll need to make sure when you link this one into here, but let me show you the first option, just linking the geometry into the popnet. So let's go inside, and for anything that is static, that is not moving, you want to create an object called static object. Static object. So this is for static collisions. And then what you want to do is you want to create a merge and merge these two together. So it doesn't really matter when you're having two collisions which one is first, which one is second. It just, the main thing is that the main output from all the collisions goes first and your simulation goes second. So let's just call it character collision. And it's very easy. In the SOP path, it means surface operator path, you just need to click on this guy and find out collision geo. So as soon as you do that, you start seeing this guy in here. And this is just the geometry representation. If you want to see a collision representation, what the particles will collide with, you have to go into collisions, and in here you have to turn on the collision guide. So if I check this guy, you start seeing something blue on top of this geometry. So if I check off the display geometry, this is what actually particles are colliding with, which is pretty low res. And you can increase the resolution in here by increasing the uniform division. So if you do something like 64, see, you're starting to capture more details from your collision. And this is good enough for simple collisions. You could just link this one and be done. You don't have to do anything else. So for more advanced collisions, I'm probably going to record a separate tutorial, or I'm going to try to fit it into this one. So now if I turn collision guide off and turn the display geometry on and hit play, see particles start to collide with this little character. Now another important thing is to make sure that in your physical attributes you have different physical attributes for different collisions. So if you want particles to bounce off the ground less, you can decrease this bounce in here, and if you want more bounce from the character, you can certainly do that. But right now the friction in both of these is not going to work, because if you go into your main pop object, this is where you find the physical qualities of the particles themselves. See, the friction is 0, so make sure you always put it to 1, and then you can control the different frictions of your collision geometry separately. So just make sure all of these are 1 except temperature, and then just control the friction in here. So if I put friction to something like 0.5 and bounce to 0.25 and hit play, see the particles start to stick to the surface a bit more, which creates a more interesting simulation. And of course, if I increase the amount of particles, something like 2000, and hit D, change it to pixels, see, the purple particles are the ones that slow down and actually stick to the surface, and the white ones are that moving pretty fast. These are simple collisions, and let me just increase this too, maybe. Okay, so this gives us more coverage. So let me check the time. Okay, we're almost 30 minutes. I'm going to show you how to link in the more advanced collision. So basically, if you go into PopNet, I'm going to create another static object. Advanced. And instead of this, I'm going to connect this. So right now we don't have anything. So in this one, you have to just link the geometry in 2 places and just change some modes. So first of all, we will link our geometry. Click on this, out collision geo, hit accept. So we have the geometry now. But now if we want to use this one instead of the default collision that we get calculated from the geometry, we have to go into collisions again. So this is your geometry, but then in here you have to change the mode to volume sample, so it will sample the volume outside. And then if you go down, this is the proxy volume where you link your volume outside. So if you click on this and click on out collision volume, hit accept, you will not see any update in here, but this will make sure that your collision is linked properly. So now if you want to take a look how your collision geometry looks like, if you click this off and turn this on, you'll see. And if you compare this to this, let me turn the display off and collision guide, you see that this one is very coarse and not very high res, but this one is pretty nice and high res. And of course you can increase the resolution of the first one. Let's go to 128, but see how long it takes to calculate it. And if you have the form in geometry, it will calculate this every frame, and your simulation will slow down a lot. But this one, you can use this, and you can actually cache this using file cache, and this is the standard workflow. You can cache your collision to disk, and then afterwards it will not have to calculate this every frame, and you will just pipe in your collisions. Everything will be fast on this end, and you will only calculate your particle simulation. So let me turn this off, turn the geometry on, and let's hit play. And there we go. Have nice collisions. Let me increase the particles amount a bit more. 3500. There we go. I'm gonna save this file for you guys and upload it. Thanks.